Welcome to the next lesson in this chapter, Publishing Domain Events. In this lesson, I'm going to show you how we will be publishing domain events inside of our system and how we can trigger domain event handlers. I will not be implementing this from scratch. Rather, I'm going to show you the implementation of this because it only contains a few components, and you can grab the updated source code under this video while I show you what are the new components that we introduced. So how are we going to implement publishing of our domain events? If you take a look in the Evently Common infrastructure project, there is a new folder called Interceptors, and inside of it we have the Publish Domain Events Interceptor class. This is a Save Changes interceptor that can hook into the process of saving changes with EF Core. We can override some of the methods that are available, and in this case I will override the saved changes async method, and I'm highlighting that the save is in the past tense, which means that this is going to execute after we have persisted our initial transaction to the database. Inside of this method, we will attempt to publish any domain events that are available on the database context. The only dependency that we have is a service scope factory, so that we can create a custom scope to publish our domain events. Now, the implementation of this method is very straightforward. We are using the EF Core database context to access the change tracker, find any entries that implement the entity base class, which is a common type in our domain project. Then we're going to select this entity entry, and using the entity type, we can access any domain events. After we have selected the domain events, we're going to clear them from the database context and return them from this method, and in the end we will end up with a list of any domain events that were raised as part of the current transaction. Then I'm going to use the service scope factory to create a new scope that is going to live for the lifetime of this method, and we're going to use the scope to resolve an iPublisher from Mediator, and finally we will loop through the domain events and publish them one by one. What are some other changes that we had to make? If we take a look at the iDomain event interface, now it is implementing the iNotification interface from Mediator, which is going to allow us to use the publish subscribe functionality of the Mediator library. This also means that I had to install an additional NuGet package in our common domain project, and this is Mediator Contract. I think this is a very small price to pay for unlocking a very powerful functionality. Another component that we need is a handler for our domain events. So inside of the common application project in the messaging folder, I introduced an iDomain event handler. It's going to inherit from the iNotification handler from Mediator, and is going to impose a generic constraint that the generic argument has to be a domain event. So this is pretty much all the scaffolding that we needed to put in place to implement domain event publishing. Now I want to make a few remarks about the reliability of this implementation. There are a few problems here that I'm not happy about. First of all, when am I publishing my domain events? I'm only doing this after I have persisted the changes that were part of the original database transaction to the database. This means that our call to save changes async from EF Core or the unit of work has already completed. All of the changes are stored in the database, and only then are we publishing the domain event. The domain event handlers could also trigger some new side effects that would be part of a different transaction, so we could risk our system ending up in an inconsistent state if one of the domain event handlers fails. Now, how are we going to solve this? We will not be doing it as part of this lesson. I will have a dedicated chapter for reliable messaging in a modular monolith later into the course, but just to mention the solution right now, we will be using the outbox and inbox patterns to implement at least once delivery and at least once processing. The next thing we need, as far as the interceptor is concerned, is to actually register it with a database context. Now, inside of the infrastructure configuration class, where we are setting up our cross-cutting concerns when it comes to dependency injection, I'm registering this interceptor as a singleton service. And then, inside of my events module in the infrastructure project, if we open up the events module class, you can see that when I'm registering my events database context, I'm introducing an interceptor, which is our publish domain event interceptor. Now I'm resolving this service using the service provider, but because this is a singleton service that's stateless, this is safe to do. Now this interceptor is going to run whenever we call save changes, and if it finds any domain events, it's going to publish them using Mediator. Of course, we also need a respective domain event handler. So in the reschedule event use case, I added an event schedule domain event handler. Right now, this is an empty handler that doesn't do anything, but I am implementing the iDomain event handler interface. This is going to get picked up with our mediator registration, and we don't need to do anything additional when it comes to wiring up the domain event handlers. So let me show you a demonstration of this. So here's what I'm going to do. I will send a PUT request from Postman, hitting the reschedule event endpoint for a particular event that I already created behind the scenes, and I want to update the start and end time for this event. So if I send this request to our API, we are going to hit the breakpoint inside of the reschedule event command handler. If I slowly go through the code that we have here, you will see that we are fetching the event from the database, doing some validation, and then we are going to call the reschedule event. Finally, we will call save changes async, and I'm going to hit continue here, and you can see a few things will happen. First of all, we are updating the event in the database and setting a new value for the end date, which means our call to save changes has completed and we persisted this transaction in the database. Then we are going to land inside of the publish domain events interceptor, which is going to go into the publish domain events async method. It's going to look for any domain events, and you can see that we do find one domain event, which is precisely the event reschedule domain event. We're going to create a service scope, resolve a publisher, and then loop through the domain events, or the one domain event that we have, and attempt to publish this domain event. Now if I hit continue again, we're going to land on the breakpoint inside of the event rescheduled domain event handler. So this is how we can easily implement publishing of our domain events using an EF Core interceptor. In this lesson, I gave you a brief overview of how you can implement publishing domain events inside of a modular monolith using EF Core interceptors. And in the next lesson, we are going to introduce a new module to our system, the users module. Welcome to the next lesson in this chapter, introducing the users module. You can grab the updated source code for this chapter under this video, and I'm going to walk you through what was introduced in the users module behind the scenes. If you grabbed the updated version of the source code, you can see that in our solution, we now have a new module under the modules users folder with 4 projects inside, matching the naming convention that we are following for introducing a new module. So we have the domain, application, infrastructure, and presentation layers inside of our users module. Now let's examine what we have inside of each of these projects. In the domain project, we have just one domain entity, the user, which contains some very simple fields: the user identifier, the email, and then the first and the last name. We also have a static factory method, creating a new user, raising a user registered domain event, and then we also have an update method that updates the user's first and last name and raises a user profile updated domain event. So this is just a simple entity that we can use to store the user's information, and this will be valuable when we are implementing authentication and authorization as part of the next chapter, as well as sharing the user data with other modules in the system, which will be the ticketing and the attendance module. We also have the user repository interface definition, some user errors such as not found and not found by the identity ID. This is something that we will introduce in the next chapter. And then we have the 2 domain events that are raised when the user is registered or the user profile is updated. Let's take a look at the application project and see what use cases we have inside. And you will see that there are only 3 use cases. The register user use case that only takes in a command with the incoming data, adds the newly created user to the repository, and persists the changes in the database. Also remember that because we implemented publishing of a domain event, we could add a respective domain event handler. In the update user use case, we have a similar story, fetching a user from the database using the repository, updating it using the method exposed on the entity, and then persisting the changes to the database that is also going to publish our domain events. And the last use case that we have is the get user query handler that's going to fetch the user from the database based on the user identifier available on the get user query. And now let's take a look at the presentation layer of the users module, and you will see that we have 3 endpoints inside for registering a user, which also allows anonymous access. Then we have the update user profile endpoint and the get user profile endpoint. So very straightforward. And finally, in the infrastructure layer, we have another database context, the user's database context, which is scoped to the user's schema. We also have a respective database migration that will create the users table in the database as well as the users schema. Inside of the users folder, we have an entity configuration and the user repository implementation. And finally, in the users module, we are configuring the database context, the repository, the respective unit of work interface, and we are also registering the endpoints for this module. The users module will serve as the foundation for implementing authentication and authorization in the next chapter, but for now, this is everything that we need to start implementing communication between our modules. The last thing that's missing is to connect the users module to our API project. So we will need to add a reference to the users infrastructure project, which is this one, and then let's go ahead and call the respective method to register this module. So I will say builder services add users module, and we need to pass in a configuration instance. So let's go ahead and do that. Another thing that we should do is to also add the respective configuration for this module. So I'm going to add this to the add module configuration array. The endpoints will be automatically registered when we call map endpoints because they are all implementing the iEndpoint interface and they are registered with dependency injection. And then the one thing we need is the respective settings files for the users module. So I will create the modules users JSON and development JSON file, and let's update this section inside to be users. I'm going to apply the same in the module users development JSON file. One more thing that we will need, other than registering the user's configuration, is also updating the call to add application. We were already registering the use cases from our events module, but let's also do the same for the users module. I'm just going to update this call here to now reference the users module application assembly. Now, the next thing that could be interesting is to be able to apply database migrations from the user's database context. If we take a look at the apply migrations method, it's only using the events database context. So let's add a respective call for the user's database context. Now I also want to show you what would happen if we tried to create a database migration. I will head over to the users module and delete the existing migration. And now if I open up the package manager console, I will set the Evently API as the startup project and the users module infrastructure project as the one that I want to create my migration in. Then I'm going to say add migration. I will say create database for the name of the migration. And then the context is going to be the user's database context. The output will live inside of my database migrations folder, and let's hit enter. In this case, you will see that I ran into an exception. And if you take a look at the exception details, you will see that it was not possible to connect to the Redis server. Now, if you're wondering why this is happening, let's take a look at the common infrastructure project where we are configuring our connection to Redis, which is this part of the code right here. So how could we fix this? Well, the problem is our Redis instance isn't running while we're applying the migration. So the simple solution could be adding a try catch statement, which is going to include the original code in the try statement. And in the fallback, we could decide to throw an exception, but that's going to prevent us from actually creating the migration. So what I could do is add a fallback and register the distributed memory cache implementation of the iDistributed cache interface. So now our code is going to attempt to connect to Redis, and if this succeeds, then everything's fine. And the fallback is going to be registering a memory cache implementation of the iDistributed cache interface. Now, if I try to run the same command again, you will see that this time we are going to succeed, and we get our create database migration in the users module. If I examine the contents of the migration, you will see that we are using the users schema, and then we have just one table inside called users. And now we will be able to run the project and the users module will be correctly integrated. And this brings us to the end of this lesson, and we are almost ready to start implementing the communication between our modules. In the next lesson, that's also going to be a very quick one, we will be scaffolding the ticketing module from scratch so that I can show you what it looks like to set up a new module starting from nothing.